This is a general equation of an addition reaction. As you can see, two reactants combine to produce a single product. Note that one of the reactant is an alkene and the product has all single bonds. This diagram shows four examples of addition reaction. When an alkene reacts with hydrogen, it forms an alkane. When an alkene reacts with water, it forms an alcohol. When an alkene reacts with a hydrogen halide, it forms a haloalkane. And when an alkene reacts with a molecule of bromine or chlorine, it forms a dihaloalkane. Now, a haloalkane is an alkane in which one of the hydrogen atom is replaced by a halogen atom, and a dihaloalkane is an alkane in which two of the hydrogen atoms are replaced by halogen atoms. Now, an elimination reaction is the reverse of an addition reaction. It occurs when a small molecule is lost from a larger compound. As you can see here, this is a larger compound, and this small molecule is lost from the compound, resulting in the formation of an alkene. An example of an elimination reaction is the formation of an alkene from an alcohol by the addition of sulfuric acid. Another example of an elimination reaction is the formation of an alkene from a haloalkane by the addition of a strong base. Now, this is the general equation of a substitution reaction. A substitution reaction occurs when one atom or functional group in a compound is replaced by a different atom or functional group, and the carbon atoms are bonded to the same number of atoms in the product as in the reactant. An example of a substitution reaction is an alcohol reacting with a hydrogen halide to produce a haloalkane. Note that the OH group of the alcohol is substituted by a chlorine atom, and the carbon atoms are bonded to the same number of atoms in the product as in the reactant. Another example of a substitution reaction is a haloalkane reacting with a hydroxide ion to produce an alcohol. Note that the chlorine atom of the haloalkane is substituted by the hydroxide ion, and the carbon atoms are bonded to the same number of atoms in the product as in the reactant. A condensation reaction occurs when reactants join together and form one larger molecule and a molecule of water. This reaction is an example of a condensation reaction. A carboxylic acid reacts with an amine to produce a larger molecule, an amide, and water. Note that the OH group of the carboxylic acid combines with the hydrogen of the amine to form water. This is another example of a condensation reaction. Here we have three amino acids combining together to produce a polypeptide and water. Each amino acid has an NH2 group at one end and a COOH group at the other end. The OH group of the COOH group of one amino acid combines with the hydrogen atom of the NH2 group of the other amino acid to form water. Now, an esterification reaction is a special type of condensation reaction in which a carboxylic acid reacts with an alcohol to form an ester and water. Note that the OH group of the acid reacts with the hydrogen atom of the OH group of the alcohol to form the water molecule. Now, a hydrolysis reaction is a reaction in which a molecule is broken apart by the addition of a water molecule. An example is the reaction of an ester with water forming an alcohol and carboxylic acid. Now, the OH group of water is added to the carbon chain containing the carbonyl group of the ester, forming a carboxylic acid, and the hydrogen atom of water is added to the alkali group of the ester, forming the alcohol. Now, this is a primary alcohol because the COH is attached to one other carbon. This is a secondary alcohol because the COH is attached to two other carbons. And this is a tertiary alcohol because the COH is attached to three other carbons. Now, primary alcohols undergo oxidation. Oxidation is the removal of hydrogen atoms or the addition of oxygen atoms. In the first step, there is a removal of hydrogen atoms from the alcohol to form an aldehyde. And in the second step, there is the addition of oxygen atom to the aldehyde to form a carboxylic acid. Secondary alcohols are oxidized to form ketones. A common oxidizing agent is potassium permanganate. When potassium permanganate gains electrons, the oxidation state is changed and the color of the solution is changed from purple to green, brown or pink, depending on the oxidation state of the potassium permanganate. Tertiary alcohols are not readily oxidized. Therefore, there is no color change when potassium permanganate is added to a tertiary alcohol.